right, so this next problem is a Gay-Lussac's law. It is number 2 on page 15. Okay, so again, when you're reading through the problems, figure out what you have. So a gas collected when the pressure is, so this is pressure, this is, so pressure is 785, this millimeters of mercury, that is mmHg. So P is going to be 785 mmHg, all right, and has a temperature of 33 degrees Celsius, all right? And remember, we want to add this to 273, all right? So it's going to become 306 Kelvin, all right? Always change your temperatures to Kelvin, volume to liter, all right? As we keep reading, what temperature, so temperature, right? So this will be my second one. Those will have to be my first. This is what we're looking for. What temperature will the gas have at standard pressure? So we have our second pressure, standard pressure. You know what that is when it's millimeters of mercury. 760 millimeters of mercury. Okay? So you know that pressure and temperature is directly related. As temperature goes up, pressure goes up because those particles are moving around more. As the particles' temperature goes down, they slow down, pressure is less. Okay? So if it's directly related, again, you know to divide. So P divided by T. Okay? So we're going to put our ones here equals P. Okay, so we have P1 over T1 equals P2 over T2. Right? And before we even get anything going, we realize that pressure is actually decreasing. So therefore, my temperature, my final answer should also be decreasing. Okay? So my next step, I'm going to cross multiply these. So I'm going to get P1 T2 equals P2 times T1. Okay? This is what I'm trying to solve for, so I'm going to divide both sides by P1. Okay? So P2 is equal to P2 over times T1 divided by P1. Okay? Insert those numbers. So our P2 is 760 millimeters of mercury times our T1, so 306 Kelvin, divided by our P1, so 785 millimeters of mercury. Okay, those cancel out. We're left in Kelvin, which is perfect. So if I plug that into the calculator, all right, I did something wrong. All right, we get 296 Kelvin. Okay, and so with this, it's decreasing. Perfect. So we know we've done it right.